Welcome back to Chem with Kess. Today we're talking about nucleophilic addition for aldehydes and ketones, and we're talking about the reaction called Wittig, or making an Ylide formation. Now this one is going to be a little bit tricky. I will have to go through a more in-depth mechanism with you for the understanding portion of this. But that's not what these cute little small videos are for. We like to get quick and to the point. So Wittig is going to normally look like it has three parts, like the one that was stated at the top. Throughout the reaction, when we're actually going through the mechanism, we can develop both of these structures, which are resonant structures of each other. So sometimes the instructors could write it that way, and they may still like write the N-butyl lithium at the bottom. So that's an option right there. This reaction is going to be considered more of under basic conditions, as well as with this reaction, your alkyl halide, which is in step 2. This alkyl halide has to be primary or secondary only, always. Now, with that primary or secondary alkyl halide, can't spell halide, we're doing a real good job today. Alkyl halide. This reaction is going to follow suit of an SN2 reaction. So in this particular problem, I drew both of them as primary. So I'm just going to quickly change this one to a methyl group right there as well. So this one is considered your secondary one, and here is considered your primary. Ooh, we having errors today. Girl, get it together. Okay, so the reaction itself, you're always going to draw again the baseline of the structure. After you're done drawing the baseline of the structure, I want you to immediately kick off the oxygen portion, leave the double bond, okay? So if we're leaving the double bond, that means that's the double bond that's right there. And then we're going to do our favorite thing and count our carbons. This is carbon 1, 2, 3, and where the negative charge or this double bond is, that would be considered your number 1 carbon, and then the rest of them. Now, the carbon of the double bond, so this is now going to be a carbon, that carbon is your carbon number 1 immediately. So once you erase that oxygen and you put that carbon there, that's immediately your carbon number 1. So for the first part, carbon number 1 here has a methyl on it. So that means we're going to draw a methyl on one side, and then it has the rest of them, which is carbons number 2 and then 3. And the same thing for the one on the bottom. Carbon number 1 currently technically has a hydrogen connected to it. So one side would be the hydrogen and the other side would be the remaining number of carbons, 2, 3, 4. Boom! The end. So anytime we see a Wittig reaction, as soon as I tell students about this reaction, it tends to be one of their favorites in this chapter. Once you see that PPH3, pH stands for a phenyl group. So just in case your instructors want to be, a little bit mean to you, they can draw 3 phenyl groups, which is 3 benzene rings connected to the phosphorus. This would be your indication that we're doing this reaction. When we do this reaction, the functional group that it ends with will always be an alkene. Let me know if you have any questions.